Hey everybody, this video lesson is going to cover predicting products for double displacement reactions, our final reaction type. If you remember from our previous video lessons, a double displacement reaction can be identified by having two aqueous solutions to begin with and two ionic substances at the end. Now, like single displacement reactions, these may or may not happen. And that's something that you're going to have to determine whether or not it happens or not in the process of predicting the products. Now, what makes this predicting products a little bit different than single displacement is you can't decide right away if the reaction happens or not. It's actually something that you decide at the end. So you may do all of this work and then at the end decide this reaction does not occur. That's kind of the sticky point of double displacement reactions, and what gives people a bad attitude towards them is because you did all this work just to result in nothing. So let's talk about the mechanism, or how the double displacement occurs. So let's take the general form of my reaction, once again A, B, and C, D, and this time I'm going to predict the products. And this is how you do it. You take the outsides and put them together. So this is kind of like the FOIL system in algebra, with the first, outsides, insides, last. Well, what we're going to do is we're going to take the outsides, the A plus the D together. Now A is the cation and D is the anion, and so they need to stay in that order, A first and D last. And then I'm going to take that and separate it between the insides. So the outsides with the insides. And this time I'm going to put B with C, or in other words, C with B. Now the reason C is before B is, again, because C was a cation here and it needs to be listed first, and B is an anion, so it needs to be listed second. So that's the mechanism. You take the outsides and put them together, and you take the insides and put them together. So the way I would describe this in text is you take and pair up one of each of the outside and one of each of the inside ions. And so you may have multiples of A or multiples of B, but you just take one of A and one of D and put them together. And you take one of C and one of B and put them together. So you pair up one of each of the outside ions and the inside ions, put the cation before the anion, and balance the charges. Here's an example that I'm going to use to explain this. I'm going to start with NaOH and MgCl2. So I'm going to take Na and combine it with Cl. So take one of each, NaCl, and then I'm going to take Mg and combine it with OH, making sure that the cation's first and the anion second. I'm going to do a quick balance of charges. +1, -1, so those are good. +2, -1. So I need to take 2 of the hydroxides for every 1 magnesium. And then I go in and erase the charges. So in that order, I pair up the outsides, pair up the insides, and then balance charges. Step 4 is where you're going to determine whether or not the reaction happens or not. And you're going to need to use another tool called the solubility table. Now, the word solubility is a vocabulary word, and it means will or will not dissolve. So you're checking your products to determine whether or not NaCl or MgOH2 will dissolve or not. You need, as I mentioned, a tool in order to do this, and it's called the solubility table. Now, I've taken a picture of this and pasted it in here, but you'll always be given this, but it's a table of cations and anions. And if you look closely across the top, you can see a list of all the cations, the common ones anyway, and down the left-hand side, the anions. And basically what you're going to do is you take each one, and you're going to determine whether or not it's soluble or insoluble. Now, the 3 options are soluble, insoluble, and slightly soluble. Now, soluble means it will dissolve, meaning it will dissolve into water and all you'll have is ions. In other words, it's an aqueous solution. Now, insoluble means that it will not dissolve, and so when these 2 ions come together, they make a solid in the solution, or in other words, a precipitate, which is characteristic of a reaction happening. And we're going to treat slightly soluble the same as not soluble. We're going to say if it's slightly soluble, it also does not dissolve. What really means is it kind of dissolves, but it kind of doesn't, but we're going to treat it as not. So basically, green is aqueous, and red and yellow mean that they do not dissolve. So here's how this table works. I find my 2 ions, sodium and chlorine. So I take the sodium and I go down where it intersects chlorine, which is the second. So this right here is green, and green means aqueous or soluble. So right here I'm going to label AQ. Now I'm going to do the same thing for magnesium, which is the second group, and I'm going to go down where it says and intersects hydroxide. So you drop magnesium, and where it intersects hydroxide is insoluble, which means it produces a solid. When it comes to determining whether or not this reaction will happen, there are really 2 outcomes. They will either both be aqueous. In that case, there is no reaction, because essentially you have two solutions that both dissolve, so you won't observe a precipitate forming. There's no gas, there's no light, there's no heat, there's no clue that a reaction happened. If both products are soluble, or in other words, both are aqueous, then no reaction occurs. Now the other outcome is one is soluble and one is insoluble. And if that happens, you get one product that's aqueous and one product that's solid, like in this example, aqueous and solid, then that means the reaction has occurred. So it's not until the very end when you decide whether or not the reaction has happened. You do all the work. You pair up the outsides, you pair up the insides, you balance the charges, and you do all this determining of solubility. And only once you've done all that work, then you can determine whether or not the reaction will happen or not. If the reaction doesn't happen, then you would write NR. And if the reaction happens, well, then you just leave the products as they're written. You did all the work, so you don't have to do any more. But let's just say these two products were both aqueous, then you just simply go up here and write NR over the top for no reaction. So in this video lesson, I've introduced you to solubility and the solubility rules. Feel free to watch this again. It's very complex. I'm not going to BS you. This is harder than what you're used to, but I think you can do it. In fact, I expect you to do it. So if you need to, ask a lot of questions, do lots of examples. I'll be here to help you. Thanks for listening. That takes care of this video lesson.